Before we start talking about statistics, we need to think about probability and understand what probability is. So there will be a definition in a moment, but as an introduction, calculating probabilities is an integral part of doing statistical analysis. So we need to look at some ways to calculate probabilities. So there are different strategies to calculate probabilities. What we'll use mainly in this class is the mathematical approach, but it's good to help see what probability really is by doing some other approaches too. So we're going to start with an example. So suppose we have four students, they have exactly identical phones. They have identical cases. There's no markings on the case to distinguish them from each other. And these four students bump into each other, and they all drop their phones face down. Hopefully they're being protected by their cases, and they just drop them. When they each pick up a phone, they realize they've done it randomly. So they bumped into each other. And I don't know if you're walking around campus, you ever notice that sometimes people don't look up when they're walking. So I can actually see this happening. Probably not four people, but it could happen. Let's think about it. How many matches, number one, owners picking up their own phone are possible because of this random picking up of phones? So let's think about it. We've got four students, each of them has a phone. What is the absolute best case scenario? That they each what? Well, I'm thinking that they each get their own phone. So everyone matches because they all get their phone. Well, what's the worst case? Well, the worst case would be that no one gets their phone. So then you're like, okay, well then one person could get their phone, two people could get their phone, three people could get their phone, or four people could. Pause and think about that. Okay, does it make sense? Everyone could get their phone, checks out to me. No one could get their phone, checks out to me. Could just one of the people get their phone? Let's see if we had, I'll just draw here. If we had four people picking up phones, could just one of them get it and then the other three be mixed up? Sure, that makes sense to me. Could, let's say, this person and this person get their phone and then the other two have the wrong phone? Yep. Well, what happens if we have this person, and this person get their phone? What has to happen by default? Well, that person has to have their phone. So three is not an option. Three is impossible. If three get their phone, the last one has to get his phone too. Number two, if none of them pick up their respective phones, there are zero matches. Make a guess of the probability of zero matches. Take a guess. Write down any number that you'd like between, let's say, 0% and 100% that you think that no one, when they do this, would get their phone. What we're looking at is actually a random process. A random process is a mechanism that can generate one of several possible outcomes at a time. Even though we cannot predict with certainty any individual outcome, we can predict the long-run pattern of these outcomes. Now, notice we're looking at long-run patterns. Long run is going to be an important concept as we go along, that things happen in the long run. Probability, we're finally getting to a definition of an outcome or event, is the long-run proportion of times an outcome event would occur if the random process was repeated over and over and over and over again under identical conditions. So this probability can be between 0 and 1 if you're looking at decimals or fractions, or between 0% and 100%. Just so we have an idea of what the value can be. You're like, well, I'm not getting it. Think about flipping a coin. If you happen to have a coin, grab it. A fair coin. Heads will come up roughly 50% of the time over actually it will come up 50% of the time over many such flips. So if we flip a coin, is there a guarantee? Is it 50-50 exactly that you're going to get? Is there a guarantee, I should say, that you will get heads the first time? No. 50-50 chance. So there's 50% likelihood you'll get a head. Okay, you flip it again. Well, your odds must change. Well, no, we're going to talk more about independence down the road, But remember, we could flip a coin, we could get 10 heads in a row or 0 heads in a row. But we're talking not 10 flips of a coin, we're talking hundreds, thousands, millions of flips. Could I flip a coin and get 10 heads in a row? Sure, it could happen. Remember that 50-50, that 50% heads, 50% tails is coming out of a random process where the coins flipped many, many times. So in this context, what is the random process? Well, in this case, what's happening? Going back to our example with the students are dropping and picking up phones at random. What are we interested in? What are we going to be measuring? The number of matches. Each time that this would happen, we would record the number of times that each student gets their phone. So what's the probability of 0 matches? There are 3 strategies that we're going to use. We're going to start with a tactile simulation. Won't be tactile in the case since we're online, but we're going to talk through it. A computer simulation, and then the exact mathematical analysis. And that's the one that we're going to focus on here. But to build to that, it does make sense to go through the others. And hopefully it'll make it more clear.